Hello, my name is Adam John Richardson. Let's talk about hypothesis testing, specifically rejecting the null hypothesis. Why do we do this? First things first, we have to work through the idea that we cannot actually prove hypotheses to be true. Let's take the example here, all dogs mark fire hydrants. When I was younger, that seemed like it was very well proven, an established theory. The problem is, even if I see 50 dogs that all exhibit this behavior, I can't actually say this hypothesis is true. All it takes is one counterexample, and I can't possibly view all of the instances of dogs out there and watch the behavior around fire hydrants. So what we end up doing, instead of trying to prove something is true, we try to disprove hypotheses. We attempt to reject them. In terms of philosophy of science, we frame our hypotheses so they can be falsified or rejected. Once we've correctly set up our hypothesis so it can be falsified, we then attempt to disprove them. So we're using an approach that harkens to philosophy, specifically logic, modus tollens. This means deny the consequent. So let's look here. If P, then Q. That's a conditional statement. The antecedent, that's P, whatever that is, fill in the blank there. Then Q is the consequent. Now, if we deny, if we disprove, if we show that Q is not true, then we can also logically show that P is not true. We use this approach when dealing with hypotheses. If all dogs always mark hydrants, there's our P, that's the antecedent, then every dog we observe will always mark. And so that's the consequent. Every dog we observe will always mark. We can attempt to disprove that in our work. And so let's take an example. We typically start by creating a research hypothesis. Perhaps that's, as written here, students who spread out studying achieve better scores than those who cram. My life is a living example of this, but that seems beyond my own context. It seems like a reasonable hypothesis. If we have this set up as our research hypothesis, we actually can't just use it as is like that, because research involving observations is messy. You might test a student on one day, and then there's a treatment that's involved, and later they get a lower score. But was it because of the treatment, or for a within subjects design, was it because they didn't get as much sleep? Or perhaps they actually had an event happen that caused some stress. There are so many conditions. We could actually give the same student the same test without any type of treatment, and they still might score differently. They might be chewing bubble gum and be so enamored of the flavor in one condition that distracts them from taking the test. If it's grape bubble gum, I get it. So instead, we have to use our understanding of the frequencies of various types of combinations of random events. This is related to our error variance here. And so we can look at a normal distribution and get a sense for how likely is this particular score to occur. And so when we restructure our research hypothesis, when we refine it, instead we state it as the following. The mean for the scores of the students who spread out studying will be, statistically speaking, higher than the mean for the students who cram. So when we say statistically speaking, we're trying to account for that error variance. Now of note, again, we can't prove this to be true, even if we see this type of event, this type of effect, that doesn't prove it to be true. Instead, we have to restate this in a way that it could be falsified. And for this, we use the null hypothesis. Our null hypothesis for this example would be the mean for the scores of the students who spread out studying will be equal, statistically speaking, we still use that same phrase, to the mean for the students who cram. And we can write this as a formulaic expression. Here we see the mean for the sample of the experimental group minus the mean for the sample of the control group. That equals 0. That's a typical expression of what we see here. And so with this in place, now using a null hypothesis, we have something that can be proven to be not true. We actually can say that it's falsifiable. We can reject it. And it's written this way. Again, we're using modus tollens. If our null hypothesis, so if that's true, and notice it says H0, that just means we expect the means to be the same. That's the meaning of the 0 there. If the null hypothesis is true, then we should observe that the means of the control group and the experimental group, statistically speaking, we always use them, are equal. And now we have it set up in such a way where we can run our experiment and there's something we can reject, which is the only way that we can actually support our work. Science works in a way where we reject things. We can support them, but that doesn't show them to be true. We have to have something that we can reject to reflect truth. And so the null hypothesis allows us to do this. I hope this helps, and I'll see you in the future. Bye.